Okay, let's recap what we've learned so far. We've made the definition that sigma r of n should be equal to the sum from j equals 0 to n of j to the r. So for example, if I want to know what sigma 2 of n is, I actually have it written down here. It's 1 squared plus 2 squared plus all the way up to n squared. And if it was concerned with sigma 3 instead, then it would be 1 cubed plus 2 cubed plus n cubed. We've also shown and proven the hockey stick identity. I have that in the last video. This will become useful in our proof. We also know, I've showed this in part 1 or 2, I forget which one, that sigma 1 of n is equal to n times n plus 1 over 2. And this is actually a polynomial of degree 2 in n. It's 1/2 n squared plus 1/2 n. So I guess the next natural question is, what is the polynomial formula for sigma 2 of n? Well, first, let's start with a realization. What is n choose 1 plus 2 times n choose 2? This might seem like it came out of nowhere, but I will show you why I'm concerned with this. Well, n choose 1 is equal to n factorial over n minus 1 factorial times 1 factorial. Well, 1 factorial is just 1. And n factorial in the numerator can be rewritten as n times n minus 1 factorial. And then in the denominator, I'll keep the n minus 1 factorial. And as you can see, the n minus 1 factorials actually cancel out, and you're left with just n. Great. Okay, let's think about 2 times n choose 2. 2 times n choose 2 is equal to 2 times n factorial over n minus 2 factorial times 2 factorial. Well, 2 factorial is just equal to 2, so those will cancel. And n factorial in the numerator can be rewritten as n times n minus 1 times n minus 2 factorial. Keep the denominator the same. You'll see these n minus 2 factorials cancel. And what you're left with is n times n minus 1, which is n squared minus n. So what happens if we add these guys? If we add them, we'll get n choose 1 plus 2 n choose 2 is equal to n plus n squared minus n, which is n squared, since these guys will cancel. Now, by definition, let me make this brighter. By definition, sigma 2 of n is equal to the sum from j equals 0 to n of j squared. Well, we can rewrite j using this formula. Using this, we can rewrite j. We can rewrite j squared as j choose 1 plus 2 j choose 2. So that will be the sum from j equals 0 to n of n choose 1 plus 2 n choose 2. Now I can separate this. I will get the sum from j equals 0 to n of n choose 1. Oops. These should not be n's, these should be j's. So if I separate the sum, I will get j equals 0 to n of j choose 1 plus this 2 times the sum from j equals 0 to n of j choose 2. And these sums are of the form of the hockey stick identity. Remember, the hockey stick identity tells us the sum from j equals 0 to n of j choose m is equal to n plus 1 choose m plus 1. And that's exactly what we have here. So let's simplify them using the hockey stick identity. And what we get that this is equal to n plus 1 choose 2 plus 2 n plus 1 choose 3. And now we're almost there. We've gotten rid of the sum signs. Let's simplify this. N plus 1 choose 2 is equal to n plus 1 factorial over n plus 1 minus 2 times 2 factorial. Well, n plus 1 minus 2, I'm sorry, factorial times 2 factorial. Well, n plus 1 minus 2 factorial is n minus 1 factorial, and 2 factorial is 2. So what we're left with, if we simplify the numerator, or expand it rather, we get n plus 1 times n minus 1 factorial, all over 2 times n minus 1 factorial. And then these guys will cancel, and what you're left with is n squared plus n over 2. That's this guy. Now let's look at this guy. 2 times n plus 1 choose 3 is equal to 2 times n plus 1 factorial over n minus 2 factorial times 3 factorial. This n minus 2 comes from n plus 1 minus 3. 3 factorial is 6, and 6 and the 2 cancel, and you'll get just a 3 in the denominator. And if I expand this n plus 1 factorial, I'll get n plus 1 times n minus 1 times n minus 2 factorial. And then this n minus 2 is just going to cancel with this guy. So I get 3 times n minus 2 factorial, and these guys cancel. So what I'm left with, if you expand out this polynomial, you're going to get, well, n plus 1 times n minus 1 is n squared minus 1 times n over 3, which is n cubed minus n over 3. Great, now all we have to do is add these guys, and we will have a formula for sigma 2 of n. So let's add them. Well, first let's put them over a common denominator. So n squared plus n over 2 is equal to 3n squared plus 3n over 6, and n cubed minus n over 3 is equal to 2n cubed minus 2n over 3. Over 6. So now we can add them, and we'll get sigma 2 of n is equal to 3n squared plus 3n plus 2n cubed minus 2n all over 6. Almost there. This is equal to 2n cubed. That's the cube term, plus 3n squared, and then plus 3n minus 2n is plus n, all over 6. There's two ways to simplify this. One, you can just break up the fraction and you'll get 1/3 n cubed plus 1/2 n squared plus 1/6 n. That's sigma 2 of n. But maybe you don't want to write it like that. Maybe you want to factor this. Well, this is equal to n times 2n squared plus 3n plus 1 over 6. And I have to use quadratic formula to factor this because I can't do this in my head. So that would be -3 plus or minus the square root of b squared. Well, let me just look it up. I don't think that's how you factor with quadratic formula. That gives you an idea of how far removed I am from factoring in school. So that is n plus 1 times 2n plus 1. So yeah, you just have to take my word for it. You can check it yourself. That is another way that you could write sigma 2 of n. We're done. We have a polynomial formula for this. Now, I want to mention that you could have used induction. You could have used induction to show that this is a valid formula. But that requires you to know the formula in advance. You'd have to know the formula beforehand, and then you'd just be testing it out. And I don't know about you, but I don't feel like just testing a bunch of random polynomials to see if it fits the function 1 squared plus 2 squared up to n squared. This works, and we showed it using much more interesting methods. We went through geometric series and combinatorics to arrive at an interesting result. So the next question, as you might have guessed, that we're going to ask ourselves in the next video is, what is sigma 3 of n? Which is 1 cubed plus 2 cubed plus all the way up to n cubed. I'm going to show this one. I'm going to show you how to find this guy, but that's the last one I'm going to do. And then we're going to move on from these functions, and we're going to discover a new class of functions that are of this form. Now, I'll start my index at 0. It doesn't really matter. From 0 to n of sigma r of j. This is the new function that we're going to be dealing with in a couple of videos. Anyways, I'll see you in the next time.